It's called a Watts link, and I'm gonna build it. Seems that no matter what I do sometimes, I don't ever have enough table. This is all the metal that we can pretty much get right now until the other shear arrives. It does the job. Every morning I come in here, I get the crew going. They all have to get all of their orders filled, find out what has to go out throughout the day, get everything prepped up, all the metal ready to go, and of course get as much of it back on the shelf as we can, so that way we're not catching up on orders. You want to do an interview? No. Come on, we gotta make this a reality show. And then we gotta fight.
Oh, we gotta create drama?
Yeah, we have to create lots and lots of drama. We gotta be on the verge of divorce. So the entire objective of the day is to get the Watts link installed. It's one of the best pieces that you can use, though highly complicated. Making sure you get your angles just right is difficult. Geometry of a Watts link is ridiculously important. Some people just throw it all in there and think that everything's good, but it doesn't always happen that way. Very specific angles it has to work on, so we gotta figure those angles out, take some measurements, draft all of this stuff up, and then build the sucker, and then of course install it. So the whole purpose of the Watts link is to stop this movement, all the lateral movement. So all the back and forth right now, that has to go away. This is where I'm gonna take all of these measurements and basically draft it up into a CAD file or something I can take my measurements, I can manipulate, I can move it, and I can determine the size everything needs to be. Because a Watts link, the geometry of it is very, very specific. So if you don't have it just right, it's gonna act a little funky when you're trying to drive down the roads. All of this can be done on paper. We could just sit here and draw it out and run some ratios and stuff like that, do it the old school way with a compass and track everything that way, but this just makes it 10 times easier. This is what the drawing I had yesterday. For the 4 links, the top line will represent the top link at the lowest position, or where its lowest point of travel, and then this bottom link, it will be the bottom link at its highest position. So I can get in here and I can track the actual travel of the system, and I can determine how much the axle is going to move in there. So with this geometry where I've already mapped it all out and positioned the 4 link properly, I have a total of I think less than half of an inch. Let's see here. From the center between the where the axle is going to sit to the point where it actually swings, that radius, I have less than a ½ inch of travel on my axle. So it acts almost exactly like a factory leaf spring would, so we don't have to worry too much about the axle moving too much one way or the other, inside and out. So this is to place it fore and aft on the vehicle. The Watts link, which I'm creating right now, is to stop it from moving left to right or laterally on the chassis. So you have to keep it all perfectly centered and make sure that everything runs smoothly. So with the simple measurements that I have right now, this just tells me where everything is positioned and what I need to basically fill in the blanks though. So this is kind of like a 3D points in space that I just kind of set up here and say, well, this is how much travel I have, this is the position it sits at, this is where it needs to be, and then we pretty much go from there. So with any luck, I'll have it done in a few minutes, which is more like probably an hour. Kind of in a roadblock right now, so. So a Watts link effectively keeps everything from swaying side to side. And we have a vertical section that actually pivots inside of here that's attached to a link on the bottom and a link on the top. That's kind of what I was trying to figure out where it needs to sit, because ideally at half the travel of the axle, which is the extension and compression of the airbags at maximum and minimum, right now it's knocking my alignments out of it. You want it to be basically centered or vertical, though the center link you want it vertical at half travel. So if I do that, that means that my bars would have to be lower than the lower 4 links on the lower section of it, and at the top of it, it'd have to be way up here. So I'm trying to think if I can get away with it and kind of change this around or set it up to where it's better at my intended ride height or my cruising height, but I'm kind of stuck on that right now of where exactly I need to put it, because if you have one link that's way down here and the other one's like way up here, or you know, stuffed backwards or whatever the case is, you run into some pretty crazy handling characteristics. So we're trying to minimize that as much as possible, or at least the craziness of it, and maintain the stability of it, which is why I have using the Watts link instead of a panhard or anything else like that. So it's tricky to figure out exactly where I want to put this thing. It wasn't really taken into account, I guess, when it came to my rear rails and how low they sit in line with the suspension travel of, or how much it needs to be to maintain the correct travel on my 4 links themselves. Which actually, according to this, it's a little bit different than my drawing. Actually, I need to drop this a little bit and level those and then take my measurements on it. Because I bet you I got way too much travel now. That might be the problem right there. I probably had a wrong measurement. I bet you that's what it is. See, I need to not argue with myself here. I did the wrong measurements and I came up with maximum height where I just had it. Now I need to get it at center height. I bet you it was this measurement here. 2 3/8 plus half ride travel minus top rail gives us exactly where I went wrong. Okay. And this I'm okay with. The link can be a little bit lower than the axle, just a tiny bit, but not much. And we should be good to go. Okay. Where were you on that one?
Well,
Telling me I was wrong.
are you wrong?
I was.
No.
You're supposed to call me out on that stuff. Getting a little ahead of myself, not paying attention to what I'm supposed to be doing here. You'll be sitting there putting everything together, and all of a sudden it's like, you know, you put it on there and like, wow, something doesn't look right, and then you say, ah, screw it, I must be messing with myself here mentally, and then all of a sudden you throw it all together and you realize, oh, you really did mess up something. That sucks. Ahead of myself again. To not get my brain wrapped up too much in the design of the Watts link right now, I'm just going to switch to tabs, and then I'm going to compare some of my other measurements. Doing the easy work kind of, you know, slows me, or kind of helps me refocus or reconcentrate on what I need to do. Because right now my brain is fighting what my measurements see, and it's kind of messing with me. So I tell everybody, it's, you know, your brain is what lies. The tape measure, your tools, you know, everything else like that, those don't lie, but your brain will. The tape measure tells the truth. I mean, it's like it's right there, but it's one of those things. Even I get into this point where I'm like, I have to take a step back and, you know, just refocus for a minute and you know, go from there. So I need 4 of those. We'll go from here to here. Copy, it's 4.25. 3 copies. There's 4 tabs ready to go right there. And that'll get us kind of in the ballpark where I can measure out the links and stuff like that. But I think I'm going to go back right now and double check where I'm at with everything, because these measurements are really messing with me right now, according to where everything is at. So right now I'm just going to save the tabs and the center pivots. I'm going to save those, and then once I have that, we'll be able to get all the bracketry or the bars to hold everything in place, and then we can take better measurements after that. It's best if I have a visual to do that. So we'll save these, go cut them out on the fast cut, and get everything welded in place, and then we'll see where we're at. That'll be a lot better. So basically all I did was take the parts that I just designed, and now we got to give it the code. We got to program it and tell the CNC or the fast cut what it needs to do, where it needs to move, and everything else that goes with it. So I use a program called SheetCam. It came with the machine, and I mean, everything works on it. It's awesome. Actually, this entire machine has made my life ridiculously easy. So right now I just tell it what size material it is, how many amps I'm going to run with on the machine. All of this is basically pre-programmed. Everything's ready to go. So with all these lines, I verify that each one is where I want it to be. What's awesome is once you get done with this, you just say, post it off into Mastercam, which is what this one runs. And we just blast right on through it. Perhaps the very best part is the controller. You know what I need? I need one of those gigantic toolboxes that takes up the entire rear wall, has the tables, the lights, the TV, and all that crap built into it. Yeah. We'll give me one. Okay. Give me a credit card. Yeah. A lot of people ask why I usually sand down my parts. I just hit it with some 80 grit on a DA or a dual action sander, and it kind of just, chops these corners down just a little bit, and it gives it a rough surface, because once it's on the vehicle or it's all welded in place, you can't go back and sand it down to paint it. So if you do it all beforehand, one, it makes it look a lot cleaner, and two, there's less prep work later for getting it all done. So a couple minutes in sanding and we're good to go. These are ready to install. So to get this angle, I bent it to right there. So if I just do the same thing, we're good. Using fresh dies. If you wonder why it keeps on getting stuck, these are brand new dies. I have not bent any material on these just yet, or at least no 1.25 inch. Bent a bunch of 1 inch, done some 1.5 inch. Remember when I had somebody try to break in the shop, I used this machine to do it. So really awesome unit. I like it. So since I'm not running very specific measurements for the Watts link, like exactly where it needs to sit and how, I'm just kind of winging it to where I want to see it, and I know I have the space. This portions of it is not like an exact science. It looks like I'm making it all up because I kind of am. I'm just running it by feel, if you will. And then I say, well, this one's about that long or so, and once we match them all up, this side of the tube where it starts and is going to be this side of the tube where it starts. So when I pull it out of here, they may be longer lengths on the legs, which have to be trimmed down, but this side's going to be exactly the same where the notch is. So it doesn't necessarily matter if they're the exact same size right now, as long as they have the exact same bend on them, and of course they're the exact same material. Good enough. This is the same 1.25 inch 120 wall DOM we're using for the 4 links. No different. Good stuff, very strong. I can live with that. The most important thing on this one is making sure that the compressor is off so I can be heard. The most important thing we have to worry about on this one is where the notches actually line up. So they're actually 90 degrees off of each other. So this side has to sit right behind the axle, and it will be vertical, whereas the pin side, or the bushing side, will actually be 90 degrees from that one. So when you put it up on there, the pivot itself will be able to swing while this stays nice, flat, even, and basically parallel to the floor, parallel to the deck. So we gotta make sure that our notches actually line up exactly where they are. It's cool if you do the bend before the notch, then you're almost guaranteed that when you set it on a flat surface, you'll be able to set this one up where it needs to be, you'll be able to set that one up where it needs to be, and they'll be able to, you can weld them easily. So really important that you kind of bend your tube first, and then you can easily position everything. So Try to think really easy. Flat planes, don't get carried away with it's got to be this way, it's got to be that way, and 6,000 different bends and stuff like that. It's very simple. 2 places to hold it in, 1 center pivot. That's all we really need. So I'm going to measure the gap on this one, and it's coming out close to about 1/4 inch. So that's about how much I'm going to take off the end of it. Give or take a little bit. It's not going to make that much of a difference, especially when we go to try to clean it up with a notch and everything else like that. So we'll take 1/4 inch off of each side, somewhere in that range, and then once we actually have it notched out, we'll hit it with a grinder, pair them up, and then make sure that they're both ground the exact same distance. So the other thing I need to reference on here is which side is going to go into the bender and which way the notch needs to go. So these need to go in here. This line needs to be facing the hole saw that sits inside of the notcher. So kind of important that we have that on there, otherwise I know I'll screw that up. Normally I'd go in here and just lop this off with the grinder, but I want it to be a little bit more precise, so I'm using the Rogue Fab Versa Notcher. It is lovely because it has the ability to notch in a bend. There's one. Should have done a little more careful measuring on that one. I'm gonna have to straighten that notch out a little bit, but they're both actually really close. So take it, put it onto here. And once I lop that back end off of there, we should be perfectly centered as we expect to be. That'll do. The preparation was exactly the same as before. We did the notch on it, we did the bevel, then we cleaned up all of the mill scale off the end of it, then we'll just quick acetone. These are ready to roll. Remember that cut you had on your hand last week? Acetone remembers. Quick prep on all surfaces. Nothing rocket science. You just don't want any dirt or junk or anything else like that inside your weld. Definitely don't want that. Do you know how to weld?
Not really. Why?
I don't know how to weld either. You gotta probably get on YouTube and figure out how to weld real quick.
I mean, I might be able to make a hole, but it won't look good.
Oh, well, we want it to look good. I'll figure it out like always. Don't worry, I'll take care of it. If you're lucky, you get an arc shot. If you're not, I still get a Watts link. Feel a breeze coming in. That's gonna screw everything up in one shot. All right, we'll let these cool down, and we'll get setting it all up on the truck. Polyurethane. Just another bushing material I like to use. I don't know the durometer on these, but I think they're somewhere in the 80s or so, maybe 70 something. They're still kind of soft, so they do have a little bit of flex and a little bit of movement, which translates to comfort. But unlike rubber, they'll last a lot longer. Many thanks. You are a nice lady.
Some days.
Well, these tabs have a slight bevel on them, just a tiny, tiny bit. Did I do a stupid? No, I'm good. Yeah, we're good. Probably have to reroute that, I'd say over. I think what we'll do is I'll have to level this one off, and level that one off, and then we'll just blast a couple tab welds in there. That should get it as soon as we get it measured from one side to the other. So let's just pick a point in space and go from there. Now that this is 4 inches wide, so we'll just mark the center of that, which is 2 inches. And then I think what I'll just do is pick a point in space here that I like, which will probably be about there. Let's see where that lands. Measure off the same flat surface that we cleaned up yesterday, that wheel bearing flange. It looks to be about 12 1/8 or so. So we'll just run a 12 1/8 here, and we'll do 12 1/8 here. With any luck, these two will still be in able to be put on the same side. Now, not all axles will give you this lovely ability to be mirrored or symmetrical or whatever, so that they're the same on both sides. You don't always get that. It's nice when you do, but it's not always going to happen. Go. Good. Go. Let's see if we can blast oh, I got it. Yeah. You have the biggest head I've ever seen in my entire life. Now what we're going to do is find the center of this, cut both tubes the same, and then we'll figure out how much to remove in order to put our center bushing in there, which will now have to face upward. Remember, that's centered here because right now this whole chassis still shifts side to side, so don't measure off of the chassis or anything else like that. Measure off of points that you have and points that you know, which in this case is these 2 points on the axle. They're mirrored of each other and they're based off the exact same measurement that we gained on the outside. So these are perfectly centered. Wherever we measure that center here is, that's exactly where it needs to be. I'm just going to place the square on here and I'm going to line it just kind of with my eyeballs. It can be relatively loose. It doesn't have to be, you know, precision here. We don't have to be dead on or anything else like that. We just kind of want to make sure that this is about as level as it gets. Normally I do a little bit better job on tack welding, but you know what, my bottom ones will hold, so it should be okay. See, this is already a good sign. They're the same length. And there we go. Minus the little burrs that need to come off of there, but that's pretty much dead in line with our axle and relatively straight, so we're good to go. Now I can take this measurement right here and I can subtract half the diameter of the bushing end, which is 2 inches. So if I take away an inch off of here and an inch off of here, that's exactly where the side of the hole saw needs to mate up with the tube to create the notch exactly in the center or dead center where it needs to be. So it's kind of a little bit of a cheater trick, but if you can't achieve this exceptionally well, you'll just have to go in there and, you know, take a couple of cuts and then, you know, smooth it out with the grinder, see if you can, you know, refine it and get it just a little bit closer. But this is pretty much dead on with our center reference on our axle, so we're good. All we gotta do is notch it out. We do have a little bit of a margin. I mean, the Rogue Fab tube notcher over here, this thing is insanely precise, but it's still, the hole saw chatters, everything, you know, it's not gonna be like dead on like a machine, if you will, but it's gonna be really, really close. So, go baby go. 2.3. 2.5. Take your dear sweet time on this stuff. Like seriously, if it doesn't line up, it ain't gonna work. If it's out by just a little bit, you know, you're gonna stretch your bushings out and stuff like that, and you just definitely don't want that. That right there is about how it should line up. I'm gonna prep these ends real quick and then we'll toss it on the chassis and make sure everything is still good, and then we'll line it up to get it all tacked into place. Moment of truth. Yeah, that is a little bit loose, kind of sloppy. I don't like that. So we'll definitely take those back out. I can still trim out just a tiny, tiny bit, and we're talking just finessing because I want to really pull some hairs on this one, but I'm a lot happier with that fit. That's pretty much set right there. I'm going to set the squares up on the table so that way we can have everything lined up where it actually needs to be, and then we'll get it all set in place and weld it all up. See if I can pry him out of there. Can't get in the move. Well, yesterday they wouldn't go in, now they wouldn't come out. You know what, I might have to weld them. These are dummy bushings. They're designed to take the shape of a bushing without being a bushing. Should have one there, should have one there, and somewhere around here we could probably get them to line up to the hole. Okay, so I can't get it quite to line up in each one of the holes, and the holes are not the same size as the hole that we're using in the 4 links. So I threw my dummy bushings in there, which I machined out in a previous episode. Pretty sure it was a 4-link episode that I did before. So as long as this is flat up against here, these are flat up against the tube, we lock them in place, put a couple of tack welds down, we should be just fine. Hoping just those 2 tacks on the top will hold it kind of steady for a moment. Looks a little funny. Oh, you grab that other bolt. I need the other dummy. It should be over there. You're a dummy. You're a dummy. And we're off by a slight amount. That would be our good friend distortion. Come on. I just want it to go. Yeah, this is crooked too, so this method is not going to work the way that I want it to. I can't even put that on there yet until, yeah, I need a break. I'll get it in a minute. Ugh. Today was a rather frustrating day, to say the least. So this go, I'm just going to do one side at a time here. I squared it up now with the actual table and set it up to where I have my correct spacing underneath, because before it was just a little bit off center and slightly out of whack, so I want to make sure that we have this just right. And that's the only way I can really achieve that is by making sure that everything's squared up right where it needs to be. So different approach, same idea. I also have a little bit more space here to get some good tacks on here, so. We'll line this one up the exact same way. Make sure it's nice and tight. Square it up. Come on. What happens when you try to rush through something? Like I mentioned earlier. I think I mentioned that earlier. Didn't I mention that? Rushing through stuff. Never a good idea. Right now I'm just like, oh, I really want this to be done, so I'm just rushing right on through it. Not a good idea. Yeah, I don't think I trust these all that much. Oh, let me jig this up. I don't trust this. No, come on. Huh? I don't know.
7/8?
I have no idea. It's not a 3/4.
It don't look like a 3/4.
The size is crescent. Got to be kidding me. You have it all planned out, you get moving on it, everything seems to be okay, then you hit one snag, and sometimes it just completely cascades or snowballs into one thing after another. And 9 times out of 10, I want to say that it's just that I lost my concentration on it, but boy, it's really hard to focus when everything just keeps on going one thing after the other after the other. So under no circumstances do I want any type of distortion on this. So I have to go to great lengths to make sure that everything's squared up where it needs to be and in alignment where it needs to be. No movie magic required. Look at that, okay. That's straight, that's in alignment, not wonky or crooked before. Now we just go weld the whole thing out and it's on here for good. know I said I wanted it tight, but come on. Whatever, I'll leave that there for right now. Fidget with it later. Well, I'm pretty sure what I'm gonna do is bust it out of there and then realign it, tack it back on. Just because there's almost no way to completely eliminate distortion. It's virtually impossible. You can minimize it, but that's about it. And I did my best to minimize it, but we still have a little bit, and that's normal. There's our center pivot. Grab our arm. Oh, crap. I forgot to compensate for width. Between the measurements not working the first time where I skipped over that part, maybe it's because the coffee didn't kick in, or it was the can't find half the tools or stuff's not lining up. It's, I mentioned, I think earlier where I said something on the lines of don't rush. I didn't listen to myself on that one, so I think that might have had something to do with it. I just really wanted to see this done, but man. The width of the bushing and the width of the heim joint are two different widths. So we're gonna have to make this break one direction then the other. The whole goal today was to install our center section, install our pivots, calculate and figure out where our link ends need to go on the chassis itself, and then calculate the bars that go in there. But, it's sometimes, you don't always get to go through the entire thing. Sometimes, you hit a snag or two, and, so that's where we ended up today, is at least getting all of it on the axle. The axle section is figured out, but we'll have to do the rest of it later. So that's about all I got for this episode. I really appreciate you guys watching. I'll catch you on the next round.